A small country with just 10 million inhabitants, with a language that is understood just by 15 million people in the whole world. A country without rich sources of oil. A country without access to sea. But still a country that, in a way, can be counted among giants, at least in the field of microscopy. And not only because of the past, not only thanks to the groundbreaking research of Armin DeLong and others, but especially thanks to the current and future possibilities. Yes, the Czech Republic is a small country, but may be counted among giants, thanks to the potential of the people that work here. And the heart is right here in Brno. And that's why I'm truly happy that you have decided to come to Brno, to South Moravian region, to the Czech Republic, to take part in the 16th Multinational Congress of Microscopy. Good afternoon to you all. Welcome. I do hope you did enjoy the lectures, I do hope you enjoyed the talks, and I do hope you will enjoy the perspective of distinguished guests from scientific academia, as well as from representatives of private sector. Because in the panel debate, we will talk mainly about two topics. First of all, the future of microscopy. What's ahead of us? What world should we expect, and what opportunities and threats will be ready for us that we can explore? And secondly, cooperation. Cooperation among academia and private sector. I will be asking for examples of good practice, so we can learn how to make this cooperation more effective and useful for everybody, and also for the society as a whole. The team of this conference is making a point that they want you to learn as much as possible and learn what you need to know. So do not hesitate to ask questions during the panel debate. Just raise your hand, let me know that you want to ask a question, and if it's possible, I will give you the floor to ask the question to the panelists that are right now coming to the stage. First, who is coming is an expert whose research is mainly concentrated on low voltage transmission electron microscopy. She graduated from Humboldt University in Berlin, and since 2004, she is the full-time professor at Ulm University. Ute Kaiser. Good afternoon, Professor. Thank you very much for joining us. He received the 2017 Nobel Prize in Chemistry. He has been working for MRC Laboratory of Molecular Biology in Cambridge since 1966. Truly 1966. Because he loves the atmosphere over there. And he loved it from the first moment when he came there. It was Saturday. And everybody was working. And he loved the dedication. And as my colleague, who has met dozens of Nobel Prize laureates, says, he is the most humble Nobel Prize laureate she has ever met. Richard Henderson. They say, quote, "We support a wide variety of multidisciplinary research by providing access to cutting-edge instrumentation, state-of-the-art data analysis, expertise, and training in advanced electron microscopy." When I say they, I mean SuperSTEM Laboratory in Daresbury. Its director is the next panelist of today's talk. It is Quentin Ramas. Thank you very much for coming. Now let's move from the Great Britain to the Czech Republic, to the great Czech Republic, and truly to the heart of the world of microscopy, not only here in the Czech Republic. Let's move to Brno and to add the perspective of the private sector. Two members of the private sector representatives will join us on stage. Electron microscopes that change the world. That is what is promised by the company Tescan. Its founder and CEO is joining us. It is Jaroslav Klíma. Thank you very much for coming. Thank you very much for being here with us and sharing your expertise. We are world leader for science. Says about itself the company Thermo Fisher Scientific that works, among other things, naturally also on microscopes. The site leader and the statutory director here in Brno is representing the company on stage. It is Petr Střelec. Thank you very much for coming. These are the panelists, and Nature, you can ask the questions you are interested in. Just keep in mind that we have two main topics, future of microscopy, and secondly, the cooperation, academia and private sector. Let's start with the future of microscopy. You can make one step in your field of expertise. You can make one advancement. You can change one thing. You can solve one problem that will lead to a huge improvement in your field. What kind of problem are you solving? Professor Kaiser, what would you solve?
Just one problem that is, of course, very difficult to choose. In the field of 2D materials, it is, as in all the other fields, it is the curiosity which drives us. And when we think of Einstein, who told us, I'm not special clever or I'm not special gifted, I'm just very, very curious. I mean, we may have a different idea about the first two adjectives for him, but the curiosity that is what driving us. And when we think now how to take our curiosity, we are all human beings, we should, I'm just coming, I have to say, I'm just coming from the Villa Tugendhat, and I was extremely inspired about the how plain and how functional the instrumentation there in the living aspect were. And so I'm thinking this is what we would like to have also in our field. We would like to have, we would like to be inspired as artists. We are all scientists, we are all artists. And we would like to be inspired by the functionality. And when I think of our 2D materials, they are just earning so much from the low voltage microscopy. So when we started our low voltage microscopy project called Salve, welcome, nice name, and sub-angstrom low voltage electron microscopy, then we did not think of the 2D materials. That was a development which just came in parallel. So we were thinking of single molecules. Their physical limitations were found out during the study. So these combinations, this happy marriage between 2D materials and low voltage microscopy should be further explored. So we can now have a third partner in this two, so the materials, the instrumentation, and then the calculation. And this all should be made even more practical. So like in the Villa Tugendhat, where everything has such great function. And when I think of some development in Vienna, so there with the 2D materials, they have their cars, so-called cars, the TM specimen is traveling, making very different other experiments. So this is also, we want to explore, not just also that is a world on its own, electron energy loss spectroscopy and imaging, but we would like to go further in the low temperature region. We want to measure transport properties. And something like that I have in mind, which could be maybe more advanced to make it available for others, that we have that we can get the structure and the property, and that's all on the atomic level. So there, of course, advances should be, but that is what we may discuss maybe later.
We will hope to see it to come to fruition naturally in the upcoming years. Professor Henderson, what do you think will be in the next, let's say, 5 years, question answered, that will lead to a significant step forward in the field of microscopy?
Well, it's good that you asked for one thing. I have several things that would be valuable.
Usually the panelists have.
Yeah. No, but if I'm forced to pick one thing, I would like electron microscopy, and particularly the kind of electron microscopy we do in biology, electron cryomicroscopy, to be made more accessible and less expensive. So that, for example, you know, we almost all in the audience will have a mobile phone, a smartphone, and it will be either Android or from Apple. And these phones, if you had asked for this to be made in 1965, they would have cost hundreds of millions of euros. And now they cost, a few hundred. And that's because of the investment of time and energy and effort and so on. So that's the way I would like electron microscopy to go. Although you can think of other things that will make it more expensive and more, let's say, cutting edge. The thing that will have the big impact is by making it accessible to everybody so that electron microscopy will become as popular as a smartphone in your pocket.
That's an ambitious goal, I would say. Mr. Strelec, what do you need to solve to make it as popular as an iPhone? To make sure that the electron microscopy is as popular as an iPhone in my pocket? You are the one who should make it, to the public. With Mr. Klima, this is the task for you. There's no question there. Please just grab the microphone.
It surely is.
That was a commitment, okay?
Yes. And we are committed to that, by the way. So I would first correct what you said about our company, that we are doing the science. No, we are serving the science. And I think it's close to what you were just talking about, right? So we are committed to serving science, and we should be humbly committed to serving science. That's not always the case, but we are trying to do our best on that. So if I would be answering and picking one from many, the list is probably as long as, I would pick the radiation damage problem. So all the samples which I think you're studying are getting into the zone of more and more radiation sensitive, right? Not thinking only about biological samples, but in material science as well, there is a wealth of samples, right, which do that. So solving that problem would enable another multimodal observation. So solving radiation damage, enabling tools which would enable you to study properties of those sensitive special materials would open a new world of materials, because then we would understand, right? We can design better materials, or we can understand what to do with it, etc., etc. So if I would pick one right now, I think that's the challenge which we have ahead, and then there is about 100 of others. So,
Professor Ramas, one thing that will change the field in the upcoming years?
Yes, always put on the spot with a question like this. I'll take the easier way out.
No, you won't.
And just place myself as working at a facility where we have lots of users coming through, and collaborators and friends, and offering essentially our toys, as I call them, our machines, for them to do science with us on those instruments. And if I were to pick just one, I'm pretty sure that some of them would be really upset with me for not having picked theirs. So my answer to this would be I'd really like for things, well, first of all, maybe coming back onto what Richard was saying, to be accessible, but in a way that we can all share our resources. So we specialize on one thing, and we are reasonably good at it, but a lot of the other techniques we perhaps don't specialize on as much. And I think ways to make sure we can share all our knowledge, expertise, expensive instruments, to make sure that when people come to us with a scientific question, we don't just try and appropriate that question and then claim it, we've solved this, and then sort of parade around saying this is us. I'd much rather for mechanisms to be developed where we could all sort of put it on the table and say, well, I'll do this little bit, and then I'll come to Ute to look at other things, and then we'll go to manufacturers to do other things. And perhaps they'll take a little bit of a change of optics from the community to start sharing a little bit more, or finding mechanisms whereby we can share a bit more. And that will, I think, have more of an impact than picking one topic and saying, I'll solve batteries, or I'll solve something in biology. Just having all those tools put as a shared resource for all of us.
Okay, well, let's make a prediction, or let you make a prediction about the future possibilities of microscopy, and especially the areas where microscopy can help. In upcoming years, should we expect something like nanobots working? Should we expect microscope that will be operated by AI? What do you see in the upcoming future of microscopy?
A bit of everything, I suppose. We're not very far off.
I will once again ask you for a concrete answer.
all of it is pretty much here already. We've got a lot of automation, and we've got a lot of users wanting less automation because sometimes you serendipitously come across something that automation will not have found. So in terms of tools and development, solving or finding ways to go around a beam damage, so not really solving it, you can't avoid it. If you want to look at things, you actually need to somehow tickle it or poke the sample. There's no other way. Is going to probably be the most important thing, but that will come together with also ways of looking at samples that are not beam sensitive, sort of integrating, going back to basics and integrating theory, developing theories that are now pushed by the actual experiment. We're going to almost a position where experiment is driving theory, whereby beforehand it perhaps was a little bit the other way around, or at least on somewhat of a level plane, I would think, at least in my opinion. So again, little cop out because that's several things, but I'm sure you'll get the very same answer from all of us. There's not just the one thing that will solve it all. We're at a point, and I'm blabbering, but we're at a point where the instruments are so good that we should be able to solve a lot of things. And all of what you described, the AI-driven microscopy or automation or new ways of looking at samples that we were not dreaming we could actually look at with electrons before. All of this is basically available now with a little bit more effort, hopefully.
And hopefully in even better quality and better efficacy, naturally. Mr. Klima, what are the bottlenecks right now? What are the bottlenecks for the future progress of using AI, using all the technology that Professor Ramas was just talking about? Just grab the microphone, please. Thank you.
Yes. Naturally, the automation in the microscope setup, adjustment, and set the optimized condition for the investigation, it is highly desired. In fact, when I started with my career with electron microscopes, the profession operator of the microscope, it was the profession and qualification for all the life. It was really very difficult to prepare the microscope, to take off nice pictures, etc. Nowadays, we succeeded to signify the operator's job that the person, the microscopist, can be focused on his or her science, not to lose the time with adjusting the microscope.
So the technology is serving to make it more efficient.
More efficient, definitely. And I can't say that the scientists are lazy, but they don't want to
Wow, that was a wild call if I heard that one.
Really, they would like to purchase a machine, even with a workflow. So the complete system that they need for sample preparation, the transport of the sample into the microscope, then the method how the sample should be investigated, and finally capturing the data from the sample and processing them. And nowadays, the microscopes can produce a huge amount of data. So now probably the biggest problem for us is to handle the big data and process them and evaluate them. And here is a really big space for automation and for artificial intelligence.
So what you are saying that scientists are not lazy, but they may be lazy thanks to the technology because they will still get the result.
Yes, yeah. They try, it's natural. Everybody tries to reach a result with a minimized effort.
Well, that's what's driving the evolution, as it always says in the Czech Republic. You know, the laziness is driving the evolution forward. That's a Czech saying, translated word by word. But if you have any questions, please, no comments concerning the laziness of scientists. But if you have any questions, please do not hesitate to raise your hand and ask the question so you can truly learn what you are interested in. So you can get as much information as possible. The data analysis, the huge amount of data. Professor Henderson, from your perspective, how we can tackle that? Artificial intelligence, different ways of doing experiments. How should we work on that?
Yeah, so indeed, these microscopes and these detectors do produce vast amounts of data. However, the computer industry has a lot more money and a lot more people, not only phones. And so actually, I think the computing speed, the storage speed, it is actually ahead of us. So, I know in our lab, we're producing thousands of images on every microscope every day, and they get stored. And about, say, 5 or 6 years ago, everyone had hard disks. They were about 8 terabytes each. And I can remember one postdoc worked for 3 or 4 years, and he did a lot of work, published a lot of papers. He had a good job when he left. I asked him how much data he had. He didn't know. But we went to his desk, and he had these stacks of 200 8 terabyte disks. But now it's all hidden. It's it's backed up to another site in case it burns down. And I think we have many petabytes. That's many thousands of terabytes of data, and it's all hidden. So I don't think at the moment there are enough good experiments to saturate the data with. So I think and the computer industry is going with its exponential growth faster than the electron microscopy industry is going for exponential. So I'm fairly confident about it. I don't think you need intelligent, discriminating students, research scientists, and managers to make sure that you don't waste your time collecting rubbish data and only get good data, and then you don't have a problem at all. So it's not one of the things that worries me. Other things that do are to do with the cost and how many people really want to do this, because there are other activities they could do in life. I think a good analogy is the speed and the improvement of DNA sequencing. Originally, say 50 years ago, you did, one base a day if you were lucky. But now you can send off your whole genome and have it done in an hour or two. And it costs a few $100s. It's all done by a machine that's automated. So I think other than making it inexpensive, which is the most important, I think you could follow in the track of other disciplines that have made things. So now with DNA sequencing, genomes, plasmids, and so on, you don't do anything. You send it off in the post, and you get it back by email at 6 a.m. the next day. So that would be a good way of dealing with data. You send off your sample, and then you go out and have a beer, and you chat to people, and you come back next morning at 6 a.m. and it's all been done for you. That would be a good. Anyway, that was.
Is anybody opposing this view that it would be a good way? I didn't think so. But concerning the possibilities of microscopy, I would like to talk also about other areas that are not right now using microscopes, that are not using the benefits of the field, but from your perspective maybe could benefit from the potential of microscopy. Are there any fields that you can see as a potential fields of the future concerning the development of microscopy in all the variety places and all the various, let's say, attitudes that microscopy is available to offer? Mr. Strelec.
Oh, you got me. That's a tough question. So because when I see the variety of use cases, then microscopy has got into kind of everywhere, right? So and even outside of the traditional discipline, material science, life science, and of course semicon, right? So there are things that you analyze the excavations or some historical paintings or whatever with the usage of the dual beam systems, right? So to think about where is it not yet present, I would say the question is where we can do more, right? So, and anywhere where we go for smaller things, right? And when we need multimodal information, so probably is the area. But thinking about a specific field, I would say everywhere. All what we have around us, right? It's based on the atomic structures. So if you look into that word, we can start understanding how things work, what are the features, material features, whatever. So in my mind, there is no limitation. I'm just thinking, is there an area where they really haven't heard about electron microscopy? I doubt a little bit, yeah. So because photons are too big, right? So that's everybody realizes quickly. So
Not really sure about it, but okay, let's go on.
okay, at least in this forum, that's probably no doubt. So and then you need to go for something smaller, right? And so I think it's more the question where we do use too little of the microscopy. I think chemistry is still, they use it, I would say limited. And of course, now it comes the question about the environmental microscopy, right? So the small cells where you can do reactions, etc. But it's kind of available. It's about to get used to. It's similar thing like with pharma, right? A couple of years ago, no electron microscopy, just crystallography, right? So that's what we do. We crystallize and we go for synchrotron. They slowly go for that, as the cryo-electron microscopy has shown the results, but not only the results. Then I would come to Mr. Henderson's point that it shows the simplicity, the price down, and the reliability, throughput, and all these things. It's like with this iPhone thing. So I think it is about not which area never use it. It is about the area which is resistant to the change and start using it more. And I really, outside of political science and
well, you can put a lot of things under the microscope in political science.
There is a vacuum that would solve a lot of problems with some politicians. Okay, but outside of these disciplines or I don't know, philosophy, I think every discipline can benefit from electron microscopy. So if I would be visionary, electron microscopy would conquer the world more and more and more. It would grow because we need to solve the problems of the world, and these problems, they will be solved on this atomic invisible world. We can create new materials which doesn't exist, but first you need to see it, and then by the way, to manipulate it, again, electrons can help with that. So I don't give you a really good answer on that, like this is the thing. I can't.
I do understand.
In fact, I cannot remember any field of human's activity that can exist without microscopy, not only electron microscopy, but also light optical microscopy, and I would say with charged particle optics. So that we also use not only electrons, but also ions for imaging, but also for modifying the samples. And the trend is now not only to provide the image of the investigated sample, vice versa, we try to obtain very complete information about the investigated object. So it means, besides the morphology, besides the image, we try to study also the element composition, chemical bonds, crystallinity, electric potential, and other features of the material, mechanical feature of the material, for instance, in nanoscales. So I think this is now a challenge to provide complete information about the sample. For instance, from this protein, how has been said, we also don't want to only image the proteins, but we need a full characterization. So we try to learn what protein it is. And one of the very suitable analytical method is the diffraction, which is also Professor Henderson's field where he is working. So practically, and since the illnesses, let's say viruses, but also what is now very topical are the neurology illnesses. And particularly here, we need a very, very high resolution, very high magnification for studying. It is a really difficult field of activity. And moreover, some proteins are not stable at all. We try to change the proteins into the crystallic form. And this crystallic form is not stable at the room temperature. So that's why the cryo microscopy is so important for investigation of these tiny and sensitive objects.
Biomaterials, primarily, actually.
But you see, during the discussions we had last week, we realized that also the material science needs cryomicroscopy.
Professor Kaiser, this seems like a bright future of electron microscopy. What, from your perspectives, are threats for the field in the future? What are the threats? What is the potential threat? What are the potential threats for the field of electron microscopy?
Yeah. It's maybe to come to the one point which I said at the beginning, that is the combination of material growth, the properties, the determination of the properties, and the development in the field of microscopy for the particular question. I think it sounds now as there are no open questions, but there are everywhere open questions. Everyone has his own open question. Yeah? So we are all asking ourselves, I like citations, like Goethe, for instance, said, that I may perceive whatever holds the world together in its innermost folds. I think that can be at the atomic level, that can be at the bonding level. And this is what everyone needs to discover on its own field. That is really difficult to give now a general answer. I think for everyone there is a world, and we need to go deeper into the world. And this can also be on the micrometer level. We want to see maybe dislocations better, or on the nanometer level. We want to see dislocations, how boundaries are formed, which we could not see before, in particular in new materials. Yeah? So there are these, where I'm working on these also organic 2D materials, which are just coming to the synthesis, not at all to the market. So there's so much to discover, and so the future is the combination of.
I see.
Of these 3 points, I think. Yeah.
Professor Henderson, you wanted to react? What are the potential threats for the field?
No, I was just being interested in the conversation. However, because you
I
asked
saw
me-
that you are non-verbally saying that you want to add something. But
Yeah,
sorry.
no, but there is one thing I think that would be very, very valuable, because we discuss this all the time in biology. One of the last frontiers, or there are many others, but is neurobiology, and how does the brain work? How does memory work? How does intelligence work? And people think they have ideas, but until we can take microscopy images, possibly electron microscopy images, of the entire human brain, which is, say, 200 millimeters, with sub-micron resolution in real time, sub-millisecond resolution. We're absolutely nowhere near that, actually. There's no way you can do that. There are some groups trying to work on Drosophila, which have sub-millimeter brains. So you're talking about millions and millions of times. So there are immense challenges that nobody has the answer to at the moment. So how do you cut up the brain into slices? Definitely not with fib milling. Into fine slices, and in live brains as well. So I think there are a lot of let's say front barriers to progress, that you can make lists of the problems, but there are no solutions. So
Not yet.
You have to think of them and have bright ideas and make progress that way. Yeah.
Professor Kaiser, yeah.
It came something in my mind what we really cannot solve so far. That is the structure of the amorphous material, because the atoms are too close to each other. They are not projected along. So in the inorganic field, in the crystal field. So if we could have better instrumentation, for instance, allowing tomography being at the exact level, so that we can really resolve the atomic structure of amorphous material, because the amorphous material has also very, very important, it's a huge field of important applications. This is what we cannot do so far. Just maybe in 2D so far.
Hopefully in the future. Or maybe even here in Brno. How significant is Brno on the world and European map of microscopy?
I fear that's fallen
You are
on me
in
now.
Brno. I would like to. I would just like to remind you
Of
that
course.
you are in Brno.
I will insult my hosts, all our hosts. The very wise thing to do. I'll perhaps say share one observation, which perhaps will answer that question in a obvious way, I guess, is I was struck, and we had this discussion with several other colleagues, by the fact that one of the most attended rooms and symposia at this conference was technique and instrumentation development. And that's not something you see all that often at microscopy conferences. It's mostly dominated by materials-focused sessions, be it in sort of a hard material science or soft matter. And the fact that we're here in a place that has such a long history of electron optics and instrument development, and the fact that this session was so well attended and so interesting with a lot of new developments basically illustrates how important this place is for electron optics. And we all relate the successive names of various companies, and so people show old pictures of the first machine their laboratory may have got and say, well, this one was actually developed here in Brno. So I hope that's an answer that doesn't offend anybody, but I think it was heartfelt. It's certainly an observation that I did make and others made. The hardware, the instrumentation, and the electron optics is such ingrained in the culture here, and you could see it at this conference.
Professor Henderson?
So yeah, obviously, I've been once before to Brno, but it was to a biophysics summer school. I didn't even know there was any electron microscopy here in 1995. But now, the main companies, which would be Thermo Fisher, Tescan, and De Longe, they have a large number of employees, and they're producing many good products. Whereas if you look back over 50 years, there were many other companies that used to do electron microscopy products, and they gave up. Britain had 2 or 3 companies, America had companies, there was Zeiss, there was Siemens, and they've all stopped now. And so why is it then that Brno has been so successful? And I think partly it must be to do with the educational environment and the technical skills, but all the companies have worked hard to recruit people up through the schools. They all have schools, educational programs, work experience, summer speed. So, and then it may be that partly the salaries were a little bit low at the beginning, but once you've got a lead, you can block out by competition, because the cost of entry into this field is so high. I can't see anybody starting new companies anywhere else other than in the Czech Republic. The only other comparable would be in Japan, and somehow or other they've made that into one of their national goals, to retain expertise, even though sometimes they lose out in the commercial battle. So I think, the Czech Republic and particularly Brno should be very proud of this fact. Actually, it's a wonderful thing. So we're delighted that some of the microscopes we want are being developed here, and we think it's going to grow greatly in power. So positive, yeah.
Mr. Strelec?
If I may, I will try something in the light tone and jokey level to say particularly why. We started in '93 as a kind of startup on the greenfield, but all people coming from Tesla or Institute of Scientific Instruments, right? The same is for Tescan, the same is for Dong Instruments. When I was thinking about that time, I was desperate. I was totally desperate. We have to make it, because otherwise there is no job for physicists. My colleagues, they were in the banks. They were coming into vegetable trading. They were coming into all of that. And we just were a bunch of, in our company, like 60% were physicists, right, at the very beginning, right? So, and we were like, hey, we want to do some job which is close to what we love. So I think it's in the end was the big portion of love and passion for the thing, and we just were like, at least in our culture, I can't speak for Tescan, but I believe there will be some similarity. We were so dedicated to make it. And by the way, to show these Dutch people that we can do a better job. Sorry for some. No, I mean, that was the beginning. We were trying because we were not even close to what was done up there. So we are really dedicated to go and show the world that we can do it and we can continue. And we had a huge asset, which was that we were building on what was that since the war, right? Second World War. Tradition of Tesla and Institute of Scientific Instruments. So we had the background, we had the environment, and all the universities who were basically giving education. But I think the passion and the initial impact of, if you don't do this, what of interesting job for physics we can do. At least for me, it was a motivator, and in some sense, of course, this is not anymore visible, but I think it has built a little bit of the culture.
Professor Kaiser?
Short comment, you said it already, what I feel is very important here. So long ago, we received in Jena a Tesla instrument, long ago, and it was a great excitation there, and everyone was happy. So some of the, we can say, the cradle of electron microscopy is also here in Brno. Mm-hmm. And all over the time, the university training remained. So still there is a chair for electron optics, which unfortunately in Germany we didn't manage to keep. So that is a very unique, situation here in Czech Republic, which is not in England, not in Germany. So electron optics was a big field before, and it's not taught at the university level, just only this field in Germany, not in England. So, but here it is taught. So I think that is a big point, in particular, to get students and to get curious people. Yeah.
Yep. A couple mentioned the Institute of Scientific Instruments was mentioned. I can see Professor Lazar, the head of the institute in here. Professor, may I ask you a question, please?
Yeah, sure.
Thank you very much indeed. Concerning what was said, concerning the position of the institute and the participation of the institute in the scientific research, as well as in participation with the private companies, as well as in participation with various groups from all around the world. What's the position of Brno, and what are the changes that we need to make to be even better on the world scale?
I see this is not a simple question, but...
You are the head of the institute, you will handle that.
Okay, so I understand. If we talk about the interaction between the academia and the companies and the technology transfer issues, this is definitely nothing simple. Mm-hmm. I think there's no such thing like a universal recipe how to do tech transfer and how to interact. And it seems to me that electron microscopy is very, very special in this case, because as Mr. Strelec has mentioned, they serve the scientists. I would probably better say the scientists are the main customer of this company. So it means that all this ecosystem or this environment is bound together simply. We are the customers, and we are also the source of inspiration and the source of research that pushes the technology forward. All our three guests are typical example of this. Mm-hmm. So this is really environment where we are interdependent. Mm-hmm. And that's probably the source of what pushes the technology forward, what really helps to be competitive on the international market. But if I would like to say something, what to improve, I would call for more freedom.
In which way?
Or more freedom to do research and more freedom to interact between companies and research institutions. When I, Professor DeLong, 70 years ago, started electron microscopy here in Brno, and that time we had no project calls for applied research, no competence centers, no technology transfer offices, no priorities of targeted research or whatever. And it worked. But in these days, we have all of this, and it seems to me that everything is more difficult. We are living under the burden of a huge amount of bureaucracy. And if we want to do something in common, we have to apply for projects. We are bound by the project framework. We are bound by a huge amount of I don't know, national strategic documents and European strategic documents and things like this. So my dream is to have more freedom.
Less paper. I bet every one of you saw in your mind the huge pile of paper you need to fill in for a grant, haven't you? I don't think that you will oppose this, Professor.
I have a very good story about how to deal with piles of paper and bureaucracy. And it comes from Don Casper at Brandeis University, who once organized a meeting in the Paris, in a very fancy hotel. And then afterwards, we were supposed to write a paper to justify the expense of the meeting. And I wrote mine and I submitted it. And then Casper was the chairman. About 2 years later, I said, what happened to the proceedings for our conference? And he said, I have not submitted mine. I said, what do you do with all the letters that comes from the organizer bureaucratically asking for it? He said, I put the paper in my pile. And so there's a vision of this pile. I said, what happens when the pile gets very big? And he said, I take the bottom half and I throw it in the bin. And since then, I have been following his philosophy, and I recommend this to anybody who has a difficulty with bureaucracy. So.
How many piles did you throw into the bin?
Everything goes in. Eventually, everything goes in the bin. Sometimes you do something with it on the way to the bin. But yeah, no, this is very good advice. So it liberates you, and then after this you feel free.
Yeah, I feel free, but probably I would lose funding of our institute. So that's a significant disadvantage of this approach.
But you would get even freer, I would say, In a way, actually, in a way. But let's put a finger on the cooperation. Academia and the private sector. The private sector, what do you want to change in academia? Do you cooperate more freely, more satisfyingly, and more effectively with the academia? Give us the pointers.
In fact, I believe that the academia needs really freedom in their decisions, what to investigate and how to investigate. This is some basic research that must be a part of what they want. I don't like when someone will provide guidelines to scientists what they should do, and with the companies, particularly here is very difficult in Brno because we are two competing companies, and when they cooperate with one and with both, this must be very careful and not to take care about the leakage of the information from one side to another. And yeah, sorry, it is really
it's business.
Yeah, it's also important, and that's why, for instance, SciTech at the Masaryk University is very reserved to cooperate with us because they cooperate with our competitors. It is something what is difficult, but it is also very big difference between universities. It depends on the people. For instance, Brno University of Technology is not friendly to the entrepreneurs and to do something like that. It is maybe that entrepreneur is a dirty word for some professors at the university.
That would need a change of attitude if this is true.
Yes.
I would like to hear some piece of advice for the academia. We are here to learn. You have some demands. You have something you want from them. They have for instance, they have the technology to research something. They have the minds to research something. They sometimes even have the time to research something when they fill in all the forms that are needed. Mm-hmm. But they need to know, what do you want from them? Give the pointers to the academia what they need to change to you as a private sector are cooperating happily and more frequently, and even helping them with the funding in a way.
in fact, I don't like to give any task to academia.
No, don't ask.
It must be in contrary. So it means they have the freedom to investigate, to make the science, and then we can choose, pick up the results that are suitable for us.
So what you want is let them work, and then they come to you and says, okay, we have something that seems to be cool, and you could use it in the private sector.
Must be very
That's
natural.
what you are hoping for.
It must be very natural because they can decide, but they also know the needs of the industry and the needs, the trends. So, and in let's say in Western countries, particularly in the United States, the scientists try to
reach the company.
To reach the company. So because naturally it can improve also their
funding.
Their level of standard of living.
Oh, standard for to gain some money thanks to the corporation.
Yeah. So when they try to get the money, they try to guess what we need and
concentrate on that.
To this. But it is always freedom. It is always
up to them. I understand. I know what you mean.
Voluntary, not to give some task to them.
Yeah. What's the British experience, Professor Hamas? You always seem to be, like I'm surprising you with the question.
The surprise there was the British aspect, being French and living in Britain.
Well, that's the greatest perspective you can have on Great Britain. To be honest, that's the greatest way, isn't it? From a man of Scotland.
Let's not get into issues of the kingdom. Maybe at the risk of dissenting just a little bit. I mean, you're obviously preaching to the choir, and you have a room full of microscopists, and we are all absolutely keen to collaborate and work all the time. But certainly in our experience, although we'd like to fool ourselves as academics that we are extremely important in the eyes of manufacturers, at the end of the day, I might be corrected by two other guests, but we are a really small fish in terms of market share. And we may come up with a lot of ideas and maybe drive the sort of the halo type projects that make the headlines and make the covers of journals. We don't really make those companies a whole lot of money. Most of the time, we actually ask them to give us such rebates that they're not making very much on what universities get. So,
did you experience any project that you were truly fond of, that was working in the way that you were hoping for, to have a collaboration with the private sector in a way that you imagine is the correct one?
I don't know that correct is the correct word.
Well, your perspective,
no,
it's subjective.
No,
and it's your perspective. It's absolutely fine.
We're extremely lucky to have extremely good relationships with all the manufacturers from whom we've purchased instruments. Our own instruments are a little bit special, and we have a good relationship because it's also a much smaller company. That helps. But I've also equally had a great experience working on a team project with what was FEI then and is now Thermo Fisher, and that relationship worked perfectly because there was a great interface between the R&D and the academic scientists, and this is the level at which it happens. Where it becomes a little bit complicated from an academic point of view, and I don't know whether the audience will agree, is where you start adding the business side of things, and it's almost two different worlds, and perhaps this is where the extra collaboration could come in, but I don't know whether that's a slightly idealistic point of view from my French perspective. And I don't want to start a revolution, I guess, is what I'm trying to say.
Well, 1789 was enough, but if you could describe the interface that was working properly, could you describe it? How was it working? How did you do it? Who was communicating with whom? On what level? We can, use it as an example.
It's exactly as was described. That freedom or that sharing of information, asking for, I've got a problem, can I have the circuit diagram, and can I have the cross sections, and the trust that comes with knowing that this is shared in confidence. It's not going to go out, but it is still shared as a matter of principle, and it's not a case of jumping through hoops to get that information or sort of being seen as a lesser partner in that relationship. And this happens all the time, and we all, on both sides of the table, try and make that happen. It's a case of making sure that it happens for everybody, not just for the happy few who happen to have good interlocutors or to know who to talk to at various companies.
Was there any issue concerning the publishing of the information? Because you naturally want to publish it in a scientific magazine, it takes some time, but the business, when has the result, want to use the result.
In our experience, we've been particularly lucky not to. It was from the get-go decided that this was also the team project or the various other developments we've got with our own manufacturer, Neon Company. It's always been a full scientific partnership. No issue there. But I know people will have many examples where this hasn't been the case, and perhaps that's for other people to comment there. So I count myself particularly lucky in that experience. I'm sure Richard will have the exact same experience because it's obviously worked extremely well for all sorts of developments.
Do not forget that if you want to steer the debate in a different way, if you have a question or a comment concerning this topic, the collaboration, please let us know. Professor Henderson, your experience and your tips how to make it happen in the best way.
No, we had a lot of these. I've been around a long time, so I'm getting a bit older now. So I can remember all the occasions where we needed something to be done that didn't exist. We would try and do it ourselves, and then somebody from a company would come and say, "Oh, we know how to do this much better." But many of the people who do that and go around talking to people have been in commercial business company environment and also have been in academic environment. So I would say there is a big, let's say 50 years ago, the companies were one career path. You went in and you stayed there. Academia, you were another one. You stayed in and there was a cool career path. But gradually over time, initially a few people, now more and more people, they start out in academia, they go into a company, and then they come back into academia. And I know at least, in the UK, we have a guy, Roberto Solari. He was very important in GlaxoSmithKline and pharmaceutical, but he's now back as an academic. And then there are other people, and in electron microscopy, the one I remember is Carol Vandermast, who was with Philips, and then went as a professor for a while in the university, taught physics, and then came back and then started up little companies. So actually, I think the future, that's the way things are going. There's a lot of interchange of information. There's a lot of freedom. But of course, there are industrial secrets. You don't necessarily want your best idea to be stolen, and they don't have to do any development work. You've put billions of pounds into this. So I think increased mobility will help that. And most of us spend our time trying to solve some problem. And we know we think we know what we might need. And we try to persuade the companies to do it. But if they don't, we try it ourselves and get to a certain, and then there is a lot of toing and froing, exchange of information, exchange of people. So I think it's quite healthy at the moment. And, within companies, there are individuals who cannot get the senior management to do what they want. And after a while, they get frustrated, they resign, they start their own company. It's shown that their idea was a good one. And then the big company buys the little company a few years later, and they're back into the fold of it. But of course, for everyone like that, there are other ideas that just disappear. And then that was a bad idea. So the big companies. So and it's the same in academia, actually. So I think you want to encourage mobility and freedom. And then, with startup companies, venture capitalists, big companies, you could split them up. And then same with academia. A good trend in our lab, we had 50 research groups, and one of them looked like it was going to be so successful that it was going to take over the entire lab. That was the genome sequencing. So that was a spin out. And that lab is now, the Sanger Institute now has far more people than we have. But that's what happens with companies as well. So I think the overall system of academia industry is actually quite healthy. And within it, there are individuals questioning it all the time, both in academia and industry, and the people are going back and forward. So I don't think you need to change much, but you just need to encourage people. And what you don't want is some government coming and saying, we're going to nationalize you. You want to allow this relatively liberal freedom between companies and academia. And I think it's going quite well myself. Anyway, that's a view.
I would like to divide your answer to two topics I would like to talk about. Not only the lowering barriers between academia and the private sector, but also the pitching from the academia towards the private sector. Mr. Střelec, tell me, what will persuade you? What kind of pitch will persuade you when a scientist is coming to you and saying, I have a great idea, you must do it? It will be absolutely great. How he or she should persuade you to do it?
Okay, so why? I will start with the question, right?
Okay.
So why we do things? What do you think? Why the companies do things?
To make money.
Yeah. So basically, every idea needs to have a market. So the question, and by the way, it is not this. It's the same inside a company. Our R&D or our research, when they are coming with the great ideas, unfortunately, my job to kill those ideas. So
that's the guy Professor Henderson was talking about. You know, that's the guy thanks to whom the startups are rising. Okay.
And now I'm trying to advise them. Basically, if you really want these ideas to work, tell me what's the use case. Mm-hmm. What good it will bring to our customers, to you guys, by the way. So what is the added value? So if you have a beautiful toy, it's a lovely thing. I know only one company on the world who is basically saying, oh, that's a great technical idea, let's do it. And I asked that company at the time because I was totally shocked. I will not name the company, by the way. It's just say it's Japanese. So we will develop it and blah, blah, blah. And I'm like, what for? Oh, we don't know. That doesn't matter. We develop it, we put it on the shelf, and maybe there will be some applications for it later. That's, by the way, only. In my own 30 years history in these things, it's the only one company I heard doing this. So generally speaking, yes, we research as well inside as you do, explore things, and then we let some time, we can allow like a couple of years, you allow maybe a couple of dozen years, whatever. So that's the difference. But at the end, we need to start asking this question, right? So if somebody's coming...
Excuse me, yeah, how precisely should these answers be prepared to be answered by the academia? You know, imagine that the scientist is coming. Do you need a case study? Do you need a business model? Do you need a flashing PowerPoint presentation?
I don't think they really can do the business model. Sorry, sorry for my undervaluation. But you know, if you're a scientific brain, you think differently. You go certain direction. This is not for you to create really a market study and create a good business plan and go through all that our paperwork. Yeah, we have piles of things as well.
And you know what to do with them?
Yes. Unfortunately, that method doesn't work so well in corporate. I would love... nevertheless, I have always like thousands of emails which I don't read. But okay. But they can come and say, look, there is this problem which we are having on the market. Okay, so let's pick another one. I was talking about radiation damage, but let's talk about some dynamic effects, right? So we need to understand the dynamic properties, so not only the static image, but what's really happening there. I think you may like, Professor Ute, you may like to understand how your dislocations move, right? Yeah, and where they start and where they end, and how can you stop them, right? And that's dynamic, right? That's what's happening. So if the person comes, hey, I have a nice way how to create perfect resolution atomic level video with the multimodal information, so all kind of this additional information we have been talking about. And then I would expect to say, and that probably can help people to study these locations, which, by the way, is a big market because you can make green steel stronger, you can make alumina alloys, blah, 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 right? So that kind of the level, and then probably the industry would say, oh, okay, there is a market, and they would do the rest of the work, right?
Okay, so as a scientist, I'm coming and saying, okay, I have a cool idea that can be helpful in this field that you are right now operating as a business. It can help this kind of customers. And I know that there is quite a lot of customers because some of my colleagues need these tools that I'm offering, but they don't have them. And you will say, okay, that's pretty interesting. Let's have a look in detail. Then you will evaluate, I guess, the idea.
There is one essence which I didn't mention. You need to find the right person.
Well, is your email online?
Probably not. I don't know. So no, the thing is, and I think that was to that collaboration. Yes, the structural problems which were discussed are the problems. But at the end, the successful collaboration is always between two people. So there must be on every side a person who is motivated, who is willing to cooperate, who is open to that and drives it over the roadblocks, which always there will be bumpy road, right? So the same is in here. If the academic person is coming with this proposition to not the right person, it may stay on this pile and then go to the dump, right? So that's the thing. And again, you need to consider, the ratio of the good ideas which survive, right? Or the ratio of startups which survive, right? So that's the same inside of companies, by the way. That's nothing different. 1 to 10, yeah, that's fantastic, right? So basically finding the right person, building, so the relationships, the network, it's important. So okay, I may be crazy person because I'm totally curious and whatever. So sometimes I'm not happy or happy, whatever, that I'm on the position where I am. But the advantage why I do that is that I have a chance to see things and sometimes to say, hey, you're burning, you should burn more, right? Okay. Be inspired, get motivated, do this, right? And some other people may say, that's not yet ready, that's not mature enough. So they don't have the vision, right, for the things. So finding the right person is a big thing. So having network, having relationships help with that.
Professor Ramas, what's the situation in Great Britain or in France? It's up to you. Are there dedicated people in private companies that you can reach to and talk to as a member of academia? Because that's something that is being discussed in the Czech Republic. Should private companies have somebody who will be aiming to find some ideas in the academia, should be the one who will be, simplifying the process between academia and private sector?
Yes, they are, as everywhere. But maybe if I can sort of play the devil's advocate a little bit, and we heard a little bit about how to package an idea and investigate a market. A lot of the time, as you rightly said, we don't have a clue on how to develop a business plan, but that's also because our goal is not necessarily a market, but it's knowledge. And sometimes it's perhaps more important for scientists to say, I want to develop this because it'll help me see that, and it's important for me and 3 of my friends, but that's general knowledge that is added to all our global knowledge. And sometimes that is extremely difficult to find the right interlocutor at private companies who have either experienced it as an academic initially, or who can sympathize with the fact that it's going to be expensive, that it will have zero markets, but that perhaps it's important to do. And again, maybe being a little bit too idealistic, but and I'm sure I'm preaching to the choir and playing the devil's advocate. But sometimes markets is a word that academics sort of balk at, and they say, well, actually, no, I don't care about this. I want to know. And that's what it really matters to me.
What can you offer them? What can you offer them when they come with the idea and say, okay, I have an idea. It's not finalized idea. What can you offer them?
Naturally, the idea will be checked by our product marketing department, because you see, there are two extremes in companies. The company which we used to be was so-called R&D driven company, R&D guided company. And now when we hire several Western managers, they try to change it to the market driven company. But
do you like it?
I don't like it fully, because I personally was an R&D scientist before, so I don't trust to the market investigation, and particularly our distributors and even the marketing people, they come usually with some idea. Yes, we must develop a microscope that has as good as a FEI or thermal resolution. That must be something, let's say, beam booster like Zeiss have, but everything must be by 20% cheaper than the competition. So this is usually tasks from our, not all our, but it is generally wish of all marketing people.
Okay, you definitely need somebody to be the middleman between the academia and the private sector.
It must be really in balance, and we have to take into account the newest inventions, new technologies, but also we must check whether this new technology will be accepted by the market, because in fact some R&D people claim that they will create the market for this new product. It is for a small company very difficult. Let's say that something comes from thermo-size, let's say the audience accept it much better than something what originates from unknown company. So this is
because of the trust to the brand.
Because of the trust, definitely.
Okay.
And usually the competition on they let's say salespeople claim, no, it is impossible. Should it be possible? Our R&D people already made it several years ago, but we know it is impossible. So this is big dilemma. We must be careful, but what I am now trying is to convince the market people that R&D is as equal qualified as the marketing in terms of decision what the product will be developed.
I see.
And naturally, there is also calculation very important, and we have to check whether the costs we need for the development and starting the production, and the money we need to get back.
Yeah, if is it feasible or not?
Yeah.
Mr. Strelec, you wanted to react?
Yeah, thank you. I just wanted to share one thing, which basically reaction to your, which always kind of rings me the bell. Some time ago, the Mr. Ford, I mean the car, but not the David Ford, you may know from our company. But he has said that if he would have sent the marketing people to explore the market and tell him what the market wants, they would come back. We want faster horse, right? So that's exactly to your point. So never the car. So I think it's about the balance. I'm not saying that marketing is totally not useful, although I'm more on the side of Yarda. So I think it's a balance between the market pool and technology push, and we need to kind of find the right moment. So that's the sweet spot. It's extremely difficult because people who are more technical are believers on to one side. The people who are not so much technical believe in the other side. But in the collision of the interests or collision of different civilizations, because that's sometimes that big collision, good things are coming sometimes. So, and actually all the management and leadership is about one thing only, finding the dynamic balances. So.
The second point that Richard Henderson made was the people that are coming from academia to private sector and back. Professor Kaiser, what's the situation in Germany? And how do you attract people to academia when you are competing with the private sector?
At the moment, a difficult situation. But I think it a bit depends. There are always people who would like to stay in academia, in particular, as long as they are doing their PhD. So this is what works very well. Then in academia, in Germany, it's quite difficult to get permanent position. And so this is what is easier in industry. So there we lose people. But until the PhD, we have many people who we can interest during lectures and just giving them a nice atmosphere, a productive atmosphere, and a good attitude doing science.
And how do you, as a private sector, Mr. Strelec, try to persuade people? Because mentioning the PhD, the situation, I would say, is quite different in the Czech Republic. It's really hard to handle the PhD because of the cost of living and the money that people who are doing PhD at Czech universities are gaining from the PhD studies. because that's not a lot of money that they can get while studying at PhD. When do you get them? When do you get people, smart people, curious people, people who are interested in science, into private sector? At what stage of their career are you able to attract them? Any stage?
Okay, no.
Is there a moment when you are the most successful? Is it the PhD stage?
No, I think it's more like the masters. So at first I would say people are the real and only asset in the companies. There's no doubt. So companies are only good because of good people. So that's something which I will sign with my blood. So and finding good people is difficult task. So there are not enough of smart people. So what we trying to do is we're trying to engage with them, attract them since they study. On the other hand, we're trying to make sure that they study and they finish and they go through masters and they go for PhD as well, right? Because this is a trend in the Czech Republic that many companies are pulling them off the universities system, and that's bad. According to me, it's very dishonest to those people, and it's bad for the total country. Okay, so and there is one KPI. Companies love KPIs, right? So our average age through the 30, next year will be 30 years, right? So 30 years of history fluctuates between 35 and 36. So there are two options, right? So either our people are leaving soon from the company, or we are hiring people from universities, young people. So the second, of course, people usually stay relatively long with us. So that's the thing. So we are successful, I think, with attracting and hiring young, curious people. It needs a lot of cooperation, building the brand, all kind of activities which are related to that, and making the place, the culture of the company attractive for people. And believe me, young generation is different than my generation. We were used to live in more hierarchical culture, we were like, okay, this is an older guy, he knows more, etc. This is not the young generation. And actually, I'm happy that it's not the more. And I like to work with young people, and I was saying them, we are equal. We all are equal. From the lowest position in company, highest position, we are equal and I need you around the round table, that you have the same word as I have. It doesn't matter that I'm so many years in there. I'm creating stupid things, and I need you to tell me that I created a stupid thing, because otherwise I am continuing on that bad path, right? So I think cultures like that, which gives the open collaboration, which gives the space for people to be what they are, the real personalities. I don't like to use the word diversity because it's misused in the political sense to very narrow things. At the end, diversity is about diversity of opinions, backgrounds, behaviors, beliefs, I don't know what, right? Actually, we all are different personalities. So, and once you give the space to this different, which called inclusion, again, another profane word in the politician's mouth. If you really do that, and you really believe and build a culture on that, I see it's attractive for people. I see it's attractive for me. Otherwise, I would go retire and I would be fine. So,
final word, one thing. It's absolutely up to you what you want to say, but something that should be remembered by the whole audience here in the conference. Final word, Professor Ramas.
Be happy and share as much as you can, I would say. Your knowledge, your instruments, your time, and for microscopy, it's important because we're the free electron, pun intended, that links all sorts of themes and fields of science. And it's important for us to remember that we need to interact, share, and be very free with what we are very lucky to have.
Quentin Ramas, thank you very much indeed. Mr. Klima, your final word, something we should all remember.
Yeah, I am very happy that our young generation has approach to the best education. They can travel, study abroad, but they usually come back. And I wish that the people who has got the experience from abroad bring their experience and knowledge back home, and it can contribute to the let's say to the progress in our science and also in our industry.
Jaroslav Klima, thank you very much. Professor Kaiser, final word. Thank you.
Yeah, maybe just first it comes differently, and second, as you think.
Ute Kaiser, thank you very much. Mr. Strelec, what should we all remember?
I would say, let's stay all curious. Let's love what we do, and let's collaborate.
Petr Strelec, thank you very much. Professor.
Yes, so in a way, this meeting is academia mostly and industry, and particularly in Brno, that's the most important thing. But there is a wider world, and there are funding agencies which have not been involved in this discussion, and there are also the media that advertise and amplify all the research that we do, which then feeds back into the companies. So I think, my view would be it's good for people to have as broad a view as they can and discuss with as many people, not just academia and companies, but also funding agencies and advertising, interacting with the media, which is what you're doing actually. So you're helping the general advances. So encourage people to be as broad and general and interact with all the different communities in research as possible. Yeah.
Richard Henderson. Thank you very much for joining us for the panel debate that is a part of 16th Multinational Congress on microscopy. I do hope you learned something new, not only the piles of sheets of paper, but a lot of new things that you can use in your work in academia as well as in the private sector, and maybe changing the field back and forth. It's naturally up to you. I do hope you are having a great time in Brno, and you will have keeping the great time here in Brno. Thank you very much. Have a great stay. Good evening. Professor, thank you very much.